Hello and welcome to this video presentation. In this presentation, I'm going to show you how to design and draw control circuits. We're going to do an example motor circuit. Once you learn how to do the motor circuits, or once you learn how to do a control circuit, then you can progress to the ladder logic. The symbols on a control circuit, you have the actual physical picture of the switches, and you have the contacts. In ladder logic, you only have the contacts and no physical pictures. So we're going to go through it and I'm going to show you how to do this, and I'm going to explain the terminology that we use. So first, you got to have your hot and neutral rails. So you get your piece of paper and a pencil and follow along, because this is going to be an exercise where you're going to have to design and draw a control circuit. So first thing we want to do is we want to draw the rails here. Now this first rail is L1 and the second rail is L2. And what this is simulating is that, it's crooked right there. Let's see, let's get that out of there. Let's make it straight. What this is simulating is you have a hot wire, which is usually 120 volts, but it can be other voltages, just depends on the type of control circuit. You have your hot wire, which is L1, and then you have your neutral wire, which is L2. So the power, the electricity comes in on L1, goes through the circuit, and goes back on L2 and goes back to the panel. So let's draw your text. Okay, this is L1. Okay, and then this is L2. Okay, so next thing we want to do is we want to put these push buttons in here. So the start button is normally open. Okay, so the first push button that we want to put in here is a normally closed stop push button, because you're going to learn about these auxiliary contacts that's going to have to go around. They're going to be in parallel with the start button, and when you wire it in that fashion, then it makes the relay stay on when you release the start push button. So let me show you what I'm talking about here. So we're going to put in a normally closed push button. Most of the circuits that you're going to run across, they had to standardize the colors. So what that means is, if you see a red push button, more than likely it's going to be a stop push button, because that's a standard color, which means stop. So when you see like other colors, like green, orange, yellow, those are usually start push buttons, and they usually wired normally open. Most of your stop push buttons are going to be wired normally closed, and we're going to talk about that more here in a minute. So next thing we want to do is we're going to put in our normally open push button, which represents the actual start push button. It represents where you push this button right here, then you can start this motor start or relay circuit. Then what you want to do, you got to connect this stuff up. So let's go ahead and put our cord relay in there. So we can get everything straightened out here. Now we're going to name this M, short for motor. Now, you see these right here, the normally open and normally closed representation. What this means is, for each one of these rungs, see, it'd be just like a ladder that's got rungs in it. You will have numbers out here. And then this relay right here has several contacts that's associated with it. So when this energizes, it makes the contacts change state. So the normally open contacts is going to close. The normally closed contacts is going to open. So wherever you see the numbers, it's going to show you the numbers of how many rungs it is that's got the normally open contacts, and then it's going to show you how many rungs it is that's got the normally closed contacts. So you can briefly go to that particular rung, and then you'll be able to troubleshoot your circuit doing that. So we're going to talk more about this in a minute. So let's go ahead and put our lines in here. Let's see. We'll put our lines in here. I'm gonna go here. Let's see. We got one here. And we're gonna go here. We got one here. And let's go here. Okay, and then we got one that comes off of the motor and go to neutral. Okay, so now we got the stop button, we got the start button, and we got the motor relay. So what happens if I just leave it like this right here? If I push this start button, what's gonna happen? Electricity will be able to flow, and it'll be able to flow as long as this push button is pushed, and then it'll energize this motor relay, and the motor will start. Well, when I release that start push button, and it goes back to this state like it is, that motor starter is gonna shut off. So that's where the auxiliary contacts come in. And those contacts, they look like this. So let's put those in there. We're gonna put a set of normally open contacts in there. Okay, and then this is gonna be M1. Now, remember I told you, this relay has got contacts associated with it. So you may see M1, M2, M3, M4. All of those is part of M. So every time M changes, then these contacts gonna change. So this normally open contact is gonna close when M is energized. The normally closed contacts, which I'm going to show you in a minute, is going to open when M is energized. So let's draw the lines. Let me show you here. We go here, then we got to go here. We got this line, it goes here. You just remember when you're doing your schematics and stuff, I may leave a little gap in there, but it ain't supposed to be a gap in there. These lines ain't supposed to connect. So with the way that I'm doing it with the AutoCAD, they may not want to connect all the way. So you just make sure that when you're doing your diagram, just make sure that they connect all the way. So what we have here, so this is what we got. We got the stop button, got the start button, and we got the motor starter coil. This is the contacts of the motor starter coil. When you have these motor starters, or they relays or motor starters, or let me just clarify that. This would be like a relay, and this relay, the contacts off this relay will start the motor to running. If it's a motor starter, then it would have a relay associated with it, but that relay would switch higher voltage than a regular relay. So that's what a motor starter does. It allows a lot more current to go to the motor than just a regular relay, but it has a relay on it. So you'll learn more about that in a little bit later. So how does this circuit operate? Well, looking at this circuit right here, you have electricity coming in. Electricity is going to flow through the least path of resistance. So since this push button, the stop push button is closed, it goes through there. Then it goes right here, it's going to stop because it can't get across there. So when they push the push button, it can get across there. So it's going to keep on flowing, and it's going to energize this coil right here. Well, this coil got those contacts I told you about, and they call auxiliary contacts. You get different sets of them. There are normally opens and normally closed. Usually you'll have 3 sets of each on each one of those motor relay coils. So what happens is when this is energized, this contact immediately changes. It immediately closes. So what that means, when you release the start button, the power is going to come through here, or electricity is going to come through here, and then it's going to go through the least path of resistance. So if this is closed, it's going through there. And it's going to keep this motor starter energized. And it does it so fast that the motor will stay running when you release the start button. So this is a control circuit. This is the basis of a control circuit. Now you have a lot of different other things that can be controlled when this relay coil right here is energized. So let's put in some stuff. So let's say I wanted you to know if the motor was actually running. So you need a green indicator. So let's put in a little light right quick. Let's see how to do that. So what we want to do, we put this relay in here. The contacts in here. We're gonna call this one M2. Let's put in our light. So let me see if I can find a light on here. Let's see. Palette lights. Green standard. So let's put that over there. And this is going to be light 1 green. So what's going to happen is, let me move this up right here. Move component. I think that's going to line up with it. So what will happen here is, I'm going to take a wire off of here. Let's see. And then I need to take another wire off here. And let's go over to the light. And then let's close this up. So what's happening here? Remember I told you that this relay coil has got several contacts on it. So it's got 3 normally opens and 3 normally closed. This is a normally open, this is a representation of a normally open contact. This is a representation of a normally open contact. So what happens when that relay, every normally open contact is going to close when this relay is energized. So that one closes and this one closes. So what happens when this one closes? It's got a least path of resistance. That's what electricity like to do. That's why it's always looking to try to go to ground. The electricity come through here. When this is closed, it's going to go through there and it's going to make that light green. That's going to tell the person that, hey, this motor is running. That relay is energized. Now, let's look at some other stuff as far as other kind of contacts, because you got normally closed contacts also. So let's put those in there. Let me put a set of normally closed contacts in there so you can see what that looks like. So we put this in here. And we're going to call this M3. Now, what do we want this to happen? So if somebody pushes the stop, we want that light to come on. So when the motor is actually stopped, this will be true. So what we want to do is let's put in our light, and I'm going to show you how this circuit right here is going to operate. Put in our light, we put in our red light. there. Like 3, stop. So what's going to happen? Let's draw our line. And we connect it to neutral. Now, so what happens with this circuit? So when this motor, okay, the motor, let's say the motor's running. So remember I told you all the contacts, the normally open contacts, all of these contacts is going to close. And the normally closed contacts is going to open. So what will happen is while the motor is running, then you get this green light because M2 is going to be true. So that's telling you that the motor is running. What happens if something faults out with the motor? Well, or if somebody pushes the stop push button, the motor is going to stop running because electricity can't get through here. When you push this button, even for a brief second, it's going to break the electricity going to the motor. So it won't be any more power going to this motor. So this coil is going to de-energize. When this coil de-energizes, this goes back to the state that you see right here. When it goes back to the state that you see right here, then this contact right here is going to go back to that same state. And then this contact right here is going to go to the opposite state. So what's going to happen is you're going to have electricity that's going to flow through here, and it's going to light this stop button. Stop light. And that's going to let people know that the motor has stopped running. So remember, when you have control circuits, you show physical representations of the switches and you show contacts of them. Physical representation, physical representations. When in ladder logic, you just gonna see these. You'll see contacts like these. You may see, these will be drawn differently. Because what happens is with ladder logic is that it's internal inside the PLC. This stuff right here is external. So the programming inside the PLC is different. But you got to know how to be able to transfer what you learn here with what you're going to learn in ladder logic. Now, you can have all different kind of fancy, different contacts, that make this thing do stuff. And you may have a limit switch in there that after the motor gets so far, then it'll open up the relay. So let me just add you something in there. I'm going to add you a limit switch in there. So let's see what we have here. Do we have limit switches on there? Switches, push buttons. Let's see, we should have, okay, here it is, limit switches. Okay, so let's put in a limit switch. So if we had, let's see, we're gonna put this limit switch in there, limit switch number 1. So let's take this out. And then we're gonna put this limit switch in here. Move component. Well, we don't need to put it in this rung right here. We need to put a normally closed one in here because unless the machine is already there, this is not going to work because it can't get past, it won't be able to go across this terminal right here. So let's do this right here. Let's put in one like so. Limit switch. We're going to put in a normally closed one. Limit switch number 1. Okay, so see, this is the physical representation of this switch. But inside this switch, you got normally open and normally closed contacts. You got sets of them in there. So when the limit switch is closed, one set, the normally open is going to close, and the normally closed is going to open. And then when this is open, the normally open is open, and the normally closed is closed. So you just have to remember, when you have these different devices, how many different sets of contacts you got in there. Because it's going to depend on how they wired in order for how the circuit is going to work. So let's put in our lines so you can see this. Let's see. Get that here. And let's go here. Let's see. Let's move this up right here. See, I want you to see. We want to try to get it drawn good. Okay, so what happens here with this circuit? You got this limit switch. So when you start this motor, the state that it's in now, when you push this button down, since electricity likes to go through the shortest path of resistance, when you push that down right there, it's gonna go across here because it's right here. So it goes past there because that's closed. So you're going on right here. Push the button, going on right here. Then you're going through the limit switch. Now let's say this motor is got something on it that's a part of it. And then when it comes up off the limit, when it gets to the limit switch, that limit opens. Well, if the limit opens in this circuit right here, it's gonna make the motor stop also. So see, that's a function of a limit switch. It limits motion, or if it ain't motion, it's something else, it'll limit. Because once you hit that limit switch and that switch changes state, then you can make other stuff do different things. So let's just go over this circuit right here. So let's say that there's something on the conveyor, maybe a box or something. And when that box gets off of the conveyor, then this limit switch will change state. When the limit switch changes state, let's say we want that conveyor to stop when that box get off of that conveyor. So we press the start button. Since this limit switch is closed, electricity flow through there, energize the motor. Remember what I told you. The contacts off of M is going to change state. So this contact is going to close. So it's going to allow electricity to keep going through there, even when the start button is released. Now, when the device or whatever it is get to that limit switch, and after it runs for a while, then that limit switch will open and it'll make that motor stop. But while the motor is running, remember I told you all the contacts. So you have to be able to find all the contacts that comes off of M1. That comes off of M. So you got it in this run, you got it in this one, and you got one in this one. So these two right here are gonna close. Since they normally open, they are closed when M is energized. Since this one is closed, it'll open. And so that's the purpose for, let me draw you some numbers here. So normally open. So this would be rung 2 and rung 3. So then you will see a 2 and a 3. Let's see. I make it too small there. Let's do it again. Let me see. Let's do it again. So you got a 2 and a 3. And so this over here, this would be rung 1. Oh, it's not working. That would be rung 1. This would be rung 2. This would be rung 3. And this would be rung 4. So how many normally closed contacts you got? You got 1. And what rung is it in? 4. So you're going to put 4 right there. Now this is what you're going to see. This is what you will see. let's make it so it will let's move it over here. Oh, it didn't do like I wanted it to do. Just trying to move it. Let's see. Let's move it over some, like the other ones. And we'll move this one over some. So this is what happens when you see the diagram. So I know I got normally open contacts off of this relay coil in rungs 2 and 3. So if I look at rung 2, what I got? If I look at rung 3, what I got? Now, for normally closed, if I look at rung 4, I can find that M3. I can find that other contact that's in here. So this is how you're going to see control circuits. If the diagram is drawn properly, then this is what you'll see. And just remember, when you have control circuits, you have the contacts as well as the physical representation of the devices. In ladder logic, it's going to be different. So you got to know, because like in ladder logic, this stop button, it'll be named PB2 stop, but it'll look like this. It'll look like this contact because it's normally closed. See how it's normally closed? See, it's touching, so that means it's closed. So it's normally closed. And then you will see PB1 star in ladder logic, but you ain't gonna see this right here. You won't see this physical switch. You will see a contact like this. That's called PB. So that's how ladder logic and control circuits are different from each other. So we're gonna go over that more. But this is left for an exercise for you to do. So now you have actually drawn a control circuit diagram. So just take this to memory. And then we'll have another video where I can show you some more stuff about the ladder logic. So I'm gonna end this video here.